Welcome back, everyone, to day 24 of our 30-day technical deep dive. Man, I am so thrilled to have you here for this explainer today because we're going to be unlocking some serious behind-the-scenes manufacturing secrets.
So, here's a question for you. Have you ever wondered why two totally different companies can use the exact same polymer, the exact same machine, literally the exact same pigment, and yet the quality of their final products is just night and day? Like one factory is pumping out this incredibly smooth, perfectly mixed plastic, while the other guy is just struggling with a rough, weak, brittle mess. What gives, right?
Well, the answer isn't actually about the polymer or the pigment itself. Nope. The real secret ingredient here? Polymer additives. Today, we're going to see how just a tiny, tiny quantity of the right chemical can completely transform a massive batch of plastic. I mean, it literally dictates the absolute final success of the product. It's wild.
Okay, so here's our roadmap for today. First, we'll look at the secret to plastic quality. Then we'll compare internal versus external lubricants. After that, we're diving into processing aids, followed by compatibilizers and coupling agents. Then we'll look at a real-world case study, and finally, we'll wrap up with the proper R&D mindset and some really common mistakes you need to avoid.
All right, let's jump right into part one, the secret to plastic quality. So, what do these chemical heroes actually do? Basically, polymer additives are highly specialized chemicals designed to improve both how a polymer processes and how it performs in the end. Their main jobs? Making processing way easier, improving how well materials mix or disperse, significantly enhancing mechanical properties, giving you that beautiful surface finish, and ultimately making the product last a lot longer. Just a tiny dose of the right formulation, and boom, massive, measurable difference. Moving on to part two. Let's talk about lubricants, specifically internal versus external. Now, in the intense heat and pressure of manufacturing, friction is absolutely your worst enemy. And lubricants, they fight this battle on two totally different fronts. Internal lubricants work on a microscopic molecular level. They basically reduce friction between the actual polymer chains themselves. This gives you way better melt flow and drops your machine's torque. External lubricants, on the other hand, work strictly at the surface level. They're reducing friction between the polymer and the metal parts of the machine, which means super easy mold release and a really fantastic surface finish. So, totally different jobs. To ground this chemistry in the real world, let's look at PVC pipe manufacturing. In this process, balance is literally everything. If your ratio of internal to external lubricants is off even a little bit, complete disaster. You'll end up with poor fusion of the plastic, something called material played out, which is this nasty chemical residue building up inside your machinery, and just severe, ugly surface defects on the pipes. You definitely don't want that. Okay, section 3, processing aids and how we stabilize the melt. Think of processing aids as the ultimate medicine for some of the industry's biggest headaches. When you're forcing molten plastic through an extruder at super high speeds, you hit huge problems. We're talking milt fracture or the dreaded shark skin defect, where the surface comes out incredibly rough and wavy, literally like a shark's skin. But introduce a processing aid, you basically cure these issues instantly. You get better output, a beautifully smooth surface, and way faster production rates. All without that nasty dye buildup. It makes the whole process highly stable.
And this isn't just theory, right? Take LLDPE blown film extrusion. That's the process for making things like thin plastic films or stretch wrap. By simply adding a processing aid into the mix, manufacturers instantly see a massive upgrade. They get a defect-free film surface. And the best part? They can safely push their machines to run significantly faster without the material tearing. It's a total game changer for output.
All right, on to section 4, compatibilizers and coupling agents.
So imagine trying to mix oil and water. They naturally separate, right? Well, the exact same thing happens if you try to mix a polymer, like polypropylene, with natural fibers like wood flour, or even with recycled plastics. They just hate each other. They're completely incompatible. This is where a compatibilizer steps in. It acts as a chemical bridge. It literally reaches out, grabs both of these incompatible materials, and forces them to bond. This bridge gives you massive gains in impact and tensile strength. Without it, your compound is just going to fall apart the second it's put under stress. Now, closely related to those are coupling agents. While a compatibilizer blends different polymers together, a coupling agent improves the physical or chemical bond between a polymer and a mineral filler. We're talking silane, titanate, and zirconite-based agents. If you're making calcium carbonate-filled PP or glass fiber reinforced PP, coupling agents are your secret weapon. They guarantee excellent filler dispersion way higher impact strength, and much better moisture resistance. They basically lock everything together.
Let's put on our detective hats for Section 5 and look at a real-world case study. Okay, picture this. A factory gets a severe customer complaint. Their polypropylene compound is way too brittle. Naturally, the production team hits the panic button and instantly blames the quality of the filler. Typical, right? But when the investigators actually dug into the chemistry, they found the real culprit. The filler was perfectly fine. The issue? A completely missing compatibilizer. Because that essential chemical bridge wasn't there, the filler just wasn't bonding to the polymer at all, totally destroying the mechanical properties. The solution was surprisingly simple. Formulate and add the correct compatibilizer. Boom. Instantly, properties were completely restored, and the product passed every single quality test with flying colors. So how do we avoid that kind of disaster? That brings us to Section 6, R&D mindset and common mistakes.
First, let's rapid fire some top amateur mistakes that routinely destroy quality and just burn money in this industry. Number 1, overdosing lubricants. More is not always better. It just causes slip and played out. Number 2, throwing processing aids at absolutely every application, even when you really don't need them. Number 3, and this one is huge, trying to use recycled polymer without compatibilizers. That is a 100% guarantee for a weak final product. Number 4, ignoring whether a coupling agent is actually chemically compatible with your specific matrix. And number 5, the classic, removing critical additives just to cut upfront costs. Spoiler alert, it always ends up costing you an absolute fortune in rejected products down the line.
Instead, a true mastermind engineer never ever selects additives at random. They operate with a really strict professional R&D checklist. They're meticulously evaluating the specific polymer type, the precise filler type, what the end application is actually going to be used for, the exact processing method of their machines, and the specific mechanical property requirements. Only after systematically checking off every single one of those boxes do they design a custom additive package. That is how the pros do it. And that pretty much sums up our deep dive for today. We've seen how these additives, lubricants, processing aids, compatibilizers, they aren't just minor afterthoughts. They literally dictate the final destiny of your product. Now, before we wrap up, let me give you a quick sneak peek into day 25 of this Explainer series, where we'll be covering recycled plastic compounding.
Tomorrow, we are tackling some seriously tough, highly relevant challenges. We'll be breaking down post-consumer recycled versus post-industrial recycled materials. We're going to dive into the absolute nightmare that is color variation control, how to eliminate those harsh odors and contamination issues, and how to drastically improve the mechanical properties of highly unpredictable recycled batches. It's going to be packed with real-world production troubleshooting.
So I want to leave you with this one final provocative thought. When you look at your processing lines tomorrow, I want you to ask yourself, are you just indiscriminately mixing plastic together? Or are you truly engineering the perfect product from the molecular level up? Really think about the invisible chemistry happening inside those machines. If you found today's deep dive valuable and you're ready to master the complex world of compounding, drop a comment below saying Day 25 ready. Keep learning, stay curious, and I will catch you in the next Explainer.
As we come to the end of this season, let's quickly recap what we have learned today. We explored how polymer lubricant reduce friction, improve melt flow, prevent dye build up, and ensure smooth processing. We understood how processing aids enhance extrusion stability, improve surface finishing, reduce melt friction, and increase production efficiency. We also discussed the critical role of a compatibilizer, which make otherwise incomplete polymer work together by improving interfrictional adhesion, mechanical strength, and overall blend performance. Finally, we learned how coupling agents create a strong bond between filler or fiber and polymer matrix, leading to higher strength, better impact resistance, improved dimensional stability, and superior long-term durability. These additives may represent only a small percentage of formulation, but they often determine whether a product succeeds or fails in the real manufacturing environment. Selecting the right additive, using the correct dose, and understanding the section between polymer filler, pigment and processing condition. We are what separate an average formulation from an industrial grade formulation. Remember, successful polymer engineering is not about adding more additive, it's about selecting the right additive for the right application at the right contraction. Every polymer behave differently, every processing machine operate differently, and every customer requirement is unique. That is why understanding the science behind this additive is initial for anyone working in quality control, production, research and development, product development or technical service. If you found this video valuable, don't keep this knowledge to yourself. Share it with your college classmate and friend who are working in the plastic and polymer industry. Your support motivates us to create more high quality technical content based on real industry experience. If you have any question, suggest on topic you have like to cover, leave them comment section below. I personally read your comment, and many of our future videos are inspired by your question and real manufacturing challenge. If you are enjoying this complete your technology series, make sure you subscribe to the channel and turn on the notification bell so you never miss the next lesson. Our goal is to build one of the most practical and industry-focused learning platform for polymer engineering, Masterbatch technology, plastic processing, material testing, color matching, troubleshooting, and R&D formulation. And here are a small challenge before you go. Can you identify your product where lubricant processing adds compatibilizer and coupling agent are all used together? Think about the application. Write your answer in the comment and let's discuss it. In the next episode, we'll explore another advanced topic that every polymer engineer should understand with the real industry case study, formulation strategy, troubleshooting techniques, and particle manufacturing insight. Until then, keep learning, keep experimenting, keep innovating, and remember, great polymer products are never created by chance. They are engineered through knowledge, experience, and continuous improvement. Thank you for watching, and I will see you in the next video.